Unit 3, Lesson 3, this is completing the square, which is another method of solving by factoring, or another method, sorry, of solving quadratics. So already we've done the reversing of PEMDAS, and we've done solving by factoring. So this is a little bit new, completing the square. So you'll remember before, when we had the situations where you reverse PEMDAS, normally we had something like, you would have, let me see, taking up the pen again, you would have x plus 2 squared equals 4, and then you reverse all the operations outside the parentheses and then inside, and you solve, right? Well, what we're going to do is we're going to look at a way, whereas if you're given a quadratic like x squared plus 4x plus 9, you can write it like this type of thing up here, and then just do the reverse PEMDAS on it. Okay, so you're going to kind of change the form of it so that it makes it easier for you to solve. So what we're going to look at first, we're going to look at the idea of perfect squares, so quadratics that are perfect squares. So for example, if you have x plus 2 all squared, right? It's just something that you're squaring. Now if you FOIL that out, you're going to get x squared plus 2x plus 2x plus 4. Okay? That's what you get if you do x plus 2 times x plus 2 by FOIL. Then if you just simplify it all up, its total expanded form is x squared plus 4x plus 4. Alright? Look at the next one. If you FOIL this out, you're going to get x squared minus 3x plus 9. So in total it's x squared minus 6x plus 9. And the last one, x plus 7 squared, again by FOIL you get x squared plus 7x plus 49, which simplifies to x squared plus 14x plus 49. So you write the 49 in there. Right, so what pattern can we see between the numerical parts of the perfect square and the numerical parts of the expanded form? So look at that. What you have here, so look at the first one, you have 2. And when you expand it, you get x squared plus 4x plus 4. So the numerical part of the second one is minus 3. When you expand it, you get x squared minus 6x plus 9. And then the last one is x plus 7, so it becomes x squared plus 14x plus 49. So the rule is, right, when you expand out, if you have, say, x plus a squared, it gives you x squared plus 2ax plus a squared. So if you look here, this number here and this number here, right? So the number of x's, this is the x term, the number of x's is double a, and the number at the end is a squared. Okay? So let's just, by way of example, might be the easiest way to explain that. So in the following table, write the expanded form without using FOIL. So I'm thinking here that 6 is a, right? So I'm going to get x squared plus 2ax. So a is 6, 2 times a is 12, so I'm going to have 12x. And then the number at the end is a squared, so it's 36. Right? Look at the next one. You have x squared. The number of x's, we said here a is minus 5. So 2 times a is minus 10. So I get minus 10x. And the number at the end is minus 5 squared, which is plus 25. Okay? So this number here is 2 times a, and this number here is a squared. Right? So let's work backwards from that. So here you're given the expanded form. So you want to write it as x plus something squared. I'm not going to put the plus in. So x plus something squared. So look, we're looking for a. So a is half of this. So the number a is half of this because 2 times a is 8 and a squared is plus 16. So if 2 times a is 8 and a squared is 16, that means that a is 4. So that's x plus 4 squared, and that expands to be this. Look at the next one. So it's x. So you look at the number of, look at your a is minus 10. Or sorry, here you get minus 10 and 25. So a, when you multiply it by 2, gives you minus 10. And when you square it, gives 25. So it's minus 5. And the last one, what do you think it's going to be? Well, what's half of minus 18? It's minus 9. And when you square that, you get 81. So it's x minus 9 squared. Okay? So that's how we work with them. Let me go back down. Next. So we're going to look at how you solve the equation by completing the square. So, this isn't terribly difficult. It just takes a little bit of practice. So what we have is x squared plus 8x equals minus 5. Now if I look, what do I have to put on here to complete the square? Okay, so x squared plus 8x. So 8 is 2a. So that means our a is 4. And when you square that, you get 16. So I have to add 16 on here. Okay? Now because it's an equation, if I add 16 to one side, I have to add 16 to the other. So what I'm going to get then, this side here is x plus 4 squared. And over here, you get 11. Okay, so now look, you can solve it by just reversing PEMDAS on this. So by taking the square root of each side, you're going to get x plus 4 equals plus or minus the square root of 11. And then you subtract 4 from each side, you get x equals minus 4 plus or minus square root of 11. And that's your answer. Okay, so all you're doing, you're adding a number onto the end here, which makes this left side into a complete square expression. Let's look at the next one here. So what we're going to have is x squared minus 12x plus something equals 28. Now, remember, we have to complete the square. So what's half of minus 12? Half of minus 12 is minus 6. So your a is minus 6. So the number that goes on the end is a squared. So it's 36. So you're adding 36 on there, which means over here you have to add 36 as well, because it's an equation. What you do to one side, you must do to the other. So now that means that this is x minus 6 squared, and it's equal to 64. Okay, go with it then, you work it out. Square root each side to solve. So you're going to be left with x minus 6 equals plus or minus root 64, which is 8. So x equals 6 plus or minus 8. So that means that x equals 6 plus 8 is 14. 6 minus 8 is minus 2. They're your two answers. Alright? Come back down. Right, we'll go on to the next one. So a couple of quick examples just for the sake of practice, right? So what I'm going to do here is, this minus 2, I'm going to move it to the other side. Alright? So what I'm going to get is x squared plus 2x equals 2. And now I just put something at the end to complete the square, right? So let me go back for a second. X squared equals 2, and I know that I have to put something here and here. So half of 2, you get your a, half of 2 is 1, 1 squared is 1. So, complete your square, this is x plus 1 squared equals 3. Square root each side, you get x plus 1 equals plus or minus root 3. Subtract 1 from each side, you get x equals minus 1 plus or minus root 3. Okay? Next one, we're going to do x squared plus 4x equals minus 6. What do I add to complete the square? Half of 4 is 2. 2 squared is 4, so we put a plus 4 here and a plus 4 here. So we're going to get x plus 2 squared equals minus 2. Now if you look at this here, you have something squared equals minus 2. That's impossible. If you go to take the square root of each side here, look, You're asking for the square root of minus 2. Impossible. No real solutions. Okay? Now let's look at one slightly different situation. This is a bit more complicated, so hopefully we get this. So the first thing you have to do here, what I'm going to do is, I'm going to move the 30 to the other side. 3x squared minus 12x equals minus 30. Now I'm going to divide the 3 out of the left hand side. So I'm going to get 3 times x squared minus 12x equals minus 30. Alright? Now I want to complete the square in the parentheses. And actually, sorry, just let me change an error here. Go back. This here, if I divide it by 3, that should be minus 4x. X squared minus 4x. Now what do I have to add? Look what's in parentheses. What do I have to put to the ends to complete the square? Well, half of minus 4 is minus 2. Minus 2 squared is 4. Okay? Now, remember I have to add the same amount on over this side here. And it looks like I've just added 4 here. But because of the 3 outside, it's going to be multiplied by 3 in the end. So 3 times 4 means I'm actually adding on 12 over here. Alright? So what do I end up with? I end up with 3 parentheses, and it's going to be x minus 2 squared equals minus 18. And again, look, we're going to come up with this situation again, so we're going to divide both sides by 3. We're going to get x minus 2 squared equals minus 6. And in this case, you see it's no real solutions again because you have something squared equals a negative. Okay? So let's look at one more. Now here, the number 5 is on the good side of the equal to sign for you, so you can work with that. So what are we going to do? We're going to divide the left side by 5, so we have 5x squared plus 4x. That's equal to 5. 5 here. So, what do I have to add to each side? Well, half of 4 is 2 plus 4. Now what do I add on the other side? I don't just add 4, because remember this 5 outside means it's being multiplied by 5, so I have to add 20. Okay? So now what I have is 5x plus 2 squared equals 25. So that means then that x plus 2 squared, divide both sides by 5, is 5. So take the square root of each side. X plus 2 equals plus or minus root 5. Subtract 2 from each side. X equals minus 2 plus or minus root 5. Okay, we're done. So that's completing the square. Not very difficult, just takes a little bit of practice.